Hello there, this is Miss Nakayama, and today's lesson is technically 7.4a. So when you get your paper, you might want to put in, oops, not that size. 7.4a, properties of special parallelograms. So I'm going to try to talk quickly because it's a lot of material. You've got it all written down in front of you, so you don't have to do a lot of writing. Just have your highlighter ready until we get to the examples. So first and foremost, we're talking about special, special parallelograms. The first one we have is a rhombus. And a rhombus, actually before I go on, these terms right here that I'm fixing to give you all, these are the definitions of them. Okay, just like the definition of a parallelogram, quadrilateral with both pair of opposite sides parallel. A rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So in other words, yes, a square is a rhombus and a rectangle. Okay, now we're going to talk about the special properties of each one. So first off, let's go with the properties of a rhombus. Because a rhombus is a parallelogram, y'all, we have all the things that you already know. We have the definition, both opposite sides are parallel. We have both opposite sides congruent, both opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. We just talked about the definition that all four sides are congruent. So the next thing, the only new thing, really, or what's really new and what you really need to remember, is that the diagonals of a rhombus are perpendicular and they bisect the opposite angles. So if you look here, the diagonals here, you can see they're perpendicular. So this down here is reminding you that when you have a right triangle, the other two angles are always complementary. Because if that's 90, then the other two have to add up to 90. Okay? And because a rhombus is a parallelogram, and we know that opposite angles are congruent, the diagonals bisect opposite angles. So if these two, A and C, are congruent, and then they're bisected by the diagonals, then I know that 1, 2, 5, and 6 are congruent, and 3, 4, 7, and 8 are congruent. So you'll see as we work through examples how that's going to come in handy again. Okay? All right, next we have properties of rectangles. Okay? Again, it's a parallelogram. So by definition, both opposite sides are parallel. Both opposite sides are congruent. Both opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. And the definition that we had at the top tells us that we have four right angles. So what is new is that the diagonals of any rectangle are congruent. Okay? And then the last special quadrilateral we're going to talk about is a square. So the properties of a square, yes, it is a parallelogram. So by definition, both opposite sides are parallel. Both opposite sides are congruent. Both opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. And as I just mentioned, every square is a rhombus. So it has all of its properties. And every square is a rectangle. So it has all of those properties. You just got to be able to distinguish between those, but know that they hold true for all the squares. Okay? And then, last but not least, we'll go back to using diagonals to prove parallelograms. I did talk to you earlier in that the easiest way to use diagonals to prove parallelogram, a quadrilateral is a parallelogram, is that the diagonals bisect each other. If you want to prove it's a rectangle or a rhombus, if you're trying to prove a rectangle, then you just want to prove the diagonals are congruent. If you want to prove it's a rhombus, then you prove one diagonal bisects a pair of opposite angles, or the diagonals are perpendicular. I happen to think that B is easier, but you can do whichever one you want. But we will use this more in future activities. Okay, here are examples. So you want to pick up your pencil. For any rhombus QRST, any rectangle ABCD, for any square JKLM, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. Well, I'm going to draw my diagrams to begin with. So I'm going to have a rhombus QRST, a rectangle ABCD, and a square JKLM. I do want to remind y'all that when you name a parallelogram, if you're giving it to you in words like this, you have to do these in consecutive order. We talked about it in 7.1. So you can't go Q, R, S, T. It has to go in order. Doesn't matter where you start. Doesn't matter which way you go, clockwise or counterclockwise. They just have to be in the same order it's written. Okay, so on this first one, is Q always or sometimes congruent to S? Well, I hope y'all said always, because it is a parallelogram, and we know that both opposite angles are always congruent in a parallelogram. Okay? Angle Q and angle R, are they always congruent or sometimes congruent? Well, we know they're not always congruent in a parallelogram, but they are sometimes congruent if I have a square, because then they would all be 90. Actually, it could be a rectangle too. So sometimes if it's a square, if it's a rectangle, then they would be the same. Okay. Segment AB, but they were talking about that anyway. AB is equal to CD. So AB is equal to CD. Well, it's a rectangle, but more importantly, it's a parallelogram. In a parallelogram, opposite sides, we know that both opposite sides are congruent. So that means this is always true. Okay? Same rectangle. How about AB and BC? Are they always equal to each other? Well, they are not, but they would sometimes if that rectangle is a square. So if the rhombus is a square, if the rhombus is a rectangle. All right, JKL. Is segment JK perpendicular to segment KL? And I hope y'all said always, because that's the definition of a square. It has 4 right angles. If it has 4 right angles, then we know the sides are perpendicular. Back to the rectangle. Segment BC is congruent to segment CD. Okay, well, that's kind of like this one. Those are consecutive sides. Are they congruent? Well, sometimes, if my rectangle is a square. Okay. Turn to the next page. This is the last page. All right, can you conclude that the given parallelogram is a rhombus, rectangle, or square? So keep in mind, we know it's a parallelogram. Hence, you must rely only on marked information when you interpret a diagram. So I'm looking at this. There are no markings on here, but I'm told it's a parallelogram. So I know all 5 of those things that I said 3 times in this video. Do I know that SO is congruent to segment TB? Segment SO is congruent to segment TB. Can I conclude? Oh, they are telling me. Can I conclude, given that it's a parallel, that the given parallelogram is one of those? So if I'm told that segment SO is congruent to segment TP, can I conclude that it's a rhombus, rectangle, or square? I know that the diagonals are congruent, and if the diagonals are congruent, then I have a rectangle. Okay? Look at A. I know it's a parallelogram, so I know these 2 angles are congruent, and now I have these markings that tell me these angles have been bisected. So if one diagonal bisects opposite angles, then I know that I have a rhombus. And it will do it with the others. All right, 9. 9 says, I know it's a parallelogram, and I have 1 right angle, and I know this side is congruent to that side. So, what is it? Is it a rhombus, rectangle, or square? And I'm pausing because I want you to think about it. I hope y'all answered square by the definition of a square, okay? Because it's a parallelogram, both opposite sides are congruent, and if that's congruent to that, then they're all congruent. 1 right angle, they're consecutive angles are supplementary, so they're all right angles. So we have a square. All right, number 10. I have a parallelogram. Oh, and look at this. So we know the diagonals bisect each other, but with 1 tick mark on each one, I know that they're also congruent. And if they're congruent and they're perpendicular, then that would be a square, because it would be a rhombus and a rectangle. So it's a square because the diagonals are perpendicular and congruent. All right, and this last one, I have both opposite sides are parallel, because that's what a parallelogram is. But I have this little tick mark, And if it's a parallelogram, then I know these two are congruent and those two are congruent. And if I know that these two are congruent, then that means all four are congruent. And therefore, I have a rhombus by definition. Okay, number 12, find the measure of the numbered angles in each rhombus. So it's a rhombus. Both opposite sides, both opposite angles are congruent. If this is 104, then what is that angle right there? And I hope y'all are saying to yourself, well, that's going to be 180, right? Minus 104. And that, of course, is 76. So that means that angle P, QPS, is 76. So what is the measure of angle 1? The diagonals bisect the angles. So half of 76 is 38. And so that means each of these angles is 38. Okay? Number 13, it's a rhombus. So if it's a rhombus, I know that a rhombus, the diagonals are perpendicular. So measure of angle 2 is 90 degrees. Okay, and if it's 90 degrees, okay, we just did on here, we said we know these two angles have to be the same. So if that angle is 50, then you know that angle 3 is 50. And if you know if 3 is 50, we talked about earlier that these two angles have to be complementary. So if 3 is 50, then 1 is 40. Number 14. All right, again, a rhombus. And we know the measure of angle 1 has to be 90. And we know that if this is 61, then you know that's 61. And what else do you know is 61? You know that angle 2 is 61, and you know that angle 3 is 61. And 3 and 4 are complementary. So if 3 is 61, then that leaves 4 to be 29. Okay? Number 15. Whoops. Find the value of the variable for the given special parallelogram. So I know it's a rhombus, so you got to know these properties. So if it's a rhombus, what does that mean? That means all the sides are the same. So my setup equation is 3x plus 9 equals 8x minus 1. Collect your x's on one side, numbers on the other, and you get x equal to 2. Again, I'm going quickly because so feel free to speed me up, slow me down, stop, write what you need to, or pause, work ahead, and then check your work. That'll make it go that much faster. All right, a rhombus. They're pointing to this angle up here and that angle down there. So I know that this angle is the same as that angle, and I know these two are complementary because this one here in the middle has to be 90. So my setup is going to be 2x plus 8 plus 4x plus 10 equals 90. That's going to give me 6x equal to 72, and x is going to equal 12. All right, a rectangle. That angle, a rectangle by definition, is a a parallelogram with 4 right angles. This is a right angle, which means these two things have to add up to 90. So x minus 1 plus 2x plus 10 equals 90. That gives me 3x equals 81, and x equals 27. Number 18 is a rectangle. In a rectangle, the diagonals are congruent. In a parallelogram, the diagonals bisect each other. So that means all 4 of these have to be equal to each other. So my setup is just going to be 3x minus 5 equals x plus 1. On the left, 2x equals 6, and x equals 3. All right. And number 19, I have a rhombus. And in a rhombus, the diagonal bisects the angles. So that means 6x minus 2 has to equal 4x plus 8. That gives me 10 equal to 2x, and x equals 5. All right, number 20. We're on the down home stretch, y'all. Quadrilateral ABCD is a rectangle. Okay? If it's a rectangle, then I know that A, B, C, and D are all right angles. And remember, that means I also know that, I'll go mark it. You should probably mark it because it's on this same picture. All right, the diagonals are congruent and they bisect each other. So we know that all of those are the same. They're all congruent to each other. So it's just something to help you remember the properties, y'all, because it's a lot. So if AC equals 2x, so AC is the whole thing, and AE is part of it. So how are AE and AC related? Most of y'all would say that AE is half of AC, but I like to avoid those fractions. So I think about, I write an equation, I put them both down. 4x minus 1 equals 2x plus 16, but they're not equal. Which one is smaller? AE is smaller, so I'm going to go multiply that one by 2 to make it equal to the other one. So I distribute, and that gives me, nope, actually I divided by 2. So 4x minus 1 equals x plus 8. And then I come over here and say that 3x equals 9 and x equals 3. So if x equals 3, I got to find dB. And dB, of course, is the same thing as AC. So that could be 2x plus 16. So you really got to read the directions here. And of course, x we just found out was 3. So that means that dB is 21. Okay? So keep that in mind, y'all. You got to make sure, go back and always look back at what they're asking you in these problems, especially in Delta Math. Okay, 21. If AE equals x squared plus 1 and EB equals 3x plus 11, well, I can see from my diagram that those two things are congruent. They're equal to each other. Y'all, this is something we haven't had in a while, okay? You have a quadratic equation. Most of what we've been solving are just linear. That means they don't have this little exponent on there, but we have done it before because we've talked about it. So we got to bring everything to one side, which gives us x squared minus 3x minus 10, and you have to factor that. So you're looking for the factors of 10 that subtract to give you 3. And that is, if you need some extra help, extra practice in that, let me know. I can be happy to give you some problems in Delta Math to help you. But that becomes x minus 5x plus 2, which means x equals 5 or negative 2. Now, you've got to go put it back in. What are they're asking us for AC, okay? But either way, so whichever one I put it into, I got to make sure that I get a positive number, okay? So if I put in AC, if I go to AE and use x squared plus 1, no, AC, AE, pause 1 second. Okay, I'm back. So continuing this, we got x equal to 5 or x equal to negative 2. So I said AC here, but really it's AE. Okay, that should be an E. I can fix this. That is AE. Okay, AE, if I plug in 5, then that means that's 5 squared plus 1, which of course is 26, right? Or if I plug in negative 2, so this one's going to give me 26, and this one is going to give me 4 plus 1, which is 5. But that's AE, and they're asking us for AC. So AC is going to be 26 times 2, or 5 times 2. So that's which is where the 52 or the 10 come in as your answer. I just had that written down wrong. All right, look at 22. Measure of angle DAC. DAC, that's that little piece up there, and BAC. So they've given us these two parts, and those two parts have to add up to 90 because we know that angle A is a right angle. So that means 2x plus 4 plus 3x plus 1 equals 90. 5x plus 5 equals 90. Keep going. That means 5x equals 85 and x equals 17. Then I'm going to go back and go, what are they asking me for? They're asking me for the measure of angle BAC. So BAC is 3x plus 1 and x is 17. So the measure of angle BAC is 52 degrees. Okay. Next, 23. Measure of angle ABD. That's that little one up there. ABD. And CDB. That's this one down here. So how are those two related to each other? Well, I hope y'all are yelling and saying those are alternate interior angles. And we remember that they're congruent. So that means that 7x minus 31 equals 4x plus 5. 3x equals 36. And x equals 12. And then I go back and go, what are they asking me for? They're not asking me for x. They're asking me for the measure of angle ABD, which is 7 times x, x being 12, minus 31. So the measure of angle ABD is 53 degrees. All right, the last one for this diagram, we have AB plus BC equals AB plus BC equals that, and AC equals that, and the perimeter is that, find BD. So it would appear that what they gave me were, this is two sides of a triangle, this is another side of the triangle, and that is the perimeter of the triangle. So if I add up all those sides, 6x plus 2 plus 4x minus 8 equals 74. That gives me 10x equal 80 and x equals 10. And they're asking me for the length of BD. And BD is the same as AC. So I'm going to go plug that into BD is going to be 4 times x minus 8. X, of course, is 8. So that means that BD is equal to 24. All right, last grouping. Y'all made it through. Quadrilateral ABCD is a rhombus. Okay, if it's a rhombus, y'all, then you know that all sides are congruent. So mark that up. You want to remember that. We also know that the diagonals are perpendicular. Okay, so some things to help you remember. So if DK is 8, then what is KL? Yeah, it's 8. Measure of angle DML. If DML is 82, what is DKM? Okay, so I didn't put that on the diagram, but remember that the diagonals of a rhombus bisect opposite angles. So DKM is half of one of those angles. So if I know DML is 82, then I know DKM is 41. Measure of angle KAL is 2x minus 8. Find x. Well, we already marked that in our diagram, and we know that 2x minus 8 is 90. 2x equals 98, so that means x equals 49. 28. DA and AL. Find DL. Okay, so it's a parallelogram, so we know the diagonals bisect each other. So we know that DA is congruent to AL. So I know that 4x is congruent to 5x minus 3. For some reason I didn't write that down, but that of course gives us x equal to 3. And if x equals to 3, then what is the whole thing? I think it would be easier to put it right there. So if you put x in there, you get DA is 12. So if DA is 12, then AL is 12, and that makes DL 24. Okay? Last one. DM is 5y plus 2, and DK is 3y plus 6. Well, as we marked in our figure, these two expressions are equal to each other. So, unfortunately, I didn't write it down. 5y plus 2 is equal to 3y plus 6. So, 2y equals 4, and y equals 2. And if y equals 2, okay, they're asking us for KL. Well, KL is the same thing as DM and DK. So you can plug 2 into either expression, but you find out that KL is equal to 12. And that's all we got. Thank you so much for watching. Please do not hesitate to ask questions or come see me if you have any, or email me. Y'all have a great day.